Okay, we're at the 2.5-minute mark. Keep going. If you do finish up early, there's a couple shortcuts in some of these, or alternative ways to do these if you finish up. Someone's got their mic on. Just can everyone make sure their mics are muted. All right, passing the 30-30 mark. Bronze is still on the table. Okay, 4:30 marks passed. If you got stumped in any of them or you didn't quite make it, this is just an assessment. Yeah, this doesn't count towards your test, but it's there to tell you what do I need to work on. I'd say if you got this all done in 4:30 or mostly, you can feel pretty good about where you are, but maybe push it. If you got it more like around 3 minutes or less, you're probably giving the foundations time to move forward and work on some other things. Let me just take you guys' attendance real quick. Kevin's here, Julia's here, EJ's here, Kevin, Julia, EJ, Carolyn is here, I think she's going to be here, Mr. Shutt is here, Matt is here, Alicia and Josh are not here at the moment. Cool. All right, so here's what I'm going to do. I don't want to really belabor all of these, so I would like you guys to I'm going to show you guys all the solutions. A couple ways to do it on that second one up top right. And I'm going to ask you guys just to chat in if there's any of these that you would like me to go into a little more depth with. Then I will do it. So go ahead and review. I'll give you guys like a minute or so to look through these. And if something's you're curious about, ask on behalf of everyone, because if you're curious about it, probably at least one other person in the room is curious about it as well. So just chat it into the window if you do come up with one of those.
Yeah, hi, Joe.
Yeah, Kevin.
I struggled with the last one. I think, yeah, that one, yeah. Maybe most of it was because of the time constraints, and then, because to me, it's really a pretty straightforward question. There's two variables, and you find, both of them, given two equations. But I think because there was the whole time constraint and there was the last question and I was rushing, it seems like even kind of straightforward or easy questions, if it's under a time constraint and you're rushing, it's hard to get them right. So, and I was kind of looking for a shortcut.
Yeah.
For a solution, there wasn't anything. It was just solve for one and solve for the other.
I'll show you what I think there's a better way of doing that bottom right one. So I'll give you a couple comments. One, generally when you're on test day, whatever your speed is, the idea should be fast as you can, slow as you need to. Your job to be fast, your job is to get it right on the first try, not to do it faster than you can. So whatever you feel you can comfortably do it at that speed and get it right on the first try. If you're feeling like, you know what, I'm too slow at this, which, you know, if you can do that in 30 seconds, it's not too slow, that's fine. But if you feel like you're taking more like 45 seconds to a minute to do something like that, then drill it, practice it. You can get faster with this to the point where you're comfortable doing it in 30 seconds. But you definitely don't want to end up where you're always in that mindset of, if I can do it in 30 seconds, I'm trying to do it in 20 seconds on test day. If you can do it in 30 seconds, do it in 30 seconds. That's the idea. I think there's a faster way to do this, in that in general, when you have like terms, like this y and the 3y can be combined, the 2x and the x can be combined. Whenever you have like terms like that, you should be using combination, not substitution. It is universally faster. If you're used to substitution, then practice combination. It is worth it. Fewer steps, fewer mistakes, better results. So the first step, if you're doing that, is to stack it, and also just write your variables in the same order. So I'd write this as negative 2x plus y. I would just bring the 1 over to the other side, just because that's fewer terms to deal with them. And so usually I have it like this, x and y, then the number. And then we have x minus 3y also equals 1. We're solving for x, so the idea is when we have two equations like this and we're solving for something, we want to kill the other variable. If it's substitution, then you isolate the variable you want to kill, and then substitute in the other one, and that variable is now gone. That's how substitution would work. When we're stacking them, you want to get the coefficients to be the same, and don't worry about the sign. You take care of that later. So here I want y's to go away, so I want them to have the same coefficient. What I'll do is multiply by 3. And so you get negative 6x plus 3y equals 3. And then the last question is, do I add or subtract? And if they have opposite signs, you add. If they have the same signs, you subtract. So keep that sign decision keep that part separate. What do I multiply by just to get the same number? And then do I add or subtract is your next question. So let's add these to kill y, and you'll get negative 5x. These guys go away, equals 4. So x equals negative 4/5, and that's pretty fast. There's a little bit of a setup cost there. Missed. Negative 4/5. A little bit of a setup cost, but that's the kind of thing, if you're practice, you can quickly set this stuff up like this, and then it's just like one move, and you add or subtract things, and you're done. So push that. When you have like terms, you should be stacking and adding and subtracting. And again, with the goal of killing a variable, don't just add equations and see what happens. Make sure you get that coefficient to be the same on one of them first. You can add them otherwise, but you'll still have two variables, so it won't help. Any other questions? You guys all catch this one? This one's a trickier one. All right. If you guys have more questions on this, let's come back to it. I can chat more on the break. Yeah, Kevin?
I have one.
Which one is it on?
I guess it's the third one.
This one?
Yeah, I almost got the answer right. What happens is, and I did this today when I was doing the homework algebra, I think chapter 1 or 2. Some of these questions when you do algebra, like I either, so for this equation, for example, I ended up getting negative 20x equals to negative 20, and somehow I wrote the answer as minus 1 instead of it should have been 1. So I guess my problem is that sometimes I mix the negative signs, or I forget, or I do those kind of silly mistakes.
I think, yeah.
About that.
Yeah, well, everyone's got their own mistakes to make. I think a big thing is to keep that error log, and one thing you'll recognize is what kind of careless errors you make, because there's 1,000 different careless errors you can make, and you kind of defined it. So you need to be careful. When I'm doing stuff with negative positives, slow it down a little more. That's the answer. So that you've already done the hard part, I think, which is figuring out what kind of careless mistakes you make. Sometimes people, when they're dividing by a fraction, they forget which thing to flip. They just need to know, okay, slow it down here. Cool. Here we go. Let's do some GMAT problems. If you felt a little slow there, guys, push on those foundations. Again, so important to feel like confidence in your foundations. But once you're good enough, don't keep pushing on those. Then you're going to have to think about the problem solving. So check this out. I'm going to give you guys two, just a reminder, I think it's been a bit, just a quick review of data sufficiency. Remember, here's the answer choices on every data sufficiency problem. On test day, you'll get, in class, I've been showing you this as like a little cheat sheet, just as a reminder. But if you're using that grid, A, B, B, C, E, you shouldn't need any of that. These should be just totally automatic and rote by now. So a reminder of that. All I'm going to show you when I show you data sufficiency question is the question and the two statements. You should know the answers. So I'm going to give you two problems. I'm going to give you 1 minute to do them. If you have 1 minute in total to do two problems, remember our general ways that we approach problems: algebra, using numbers, and kind of logic, verbal reasoning. If you don't have much time, verbal reasoning is probably your only hope, where you have to like think it through and figure it out. So I'd like you guys to try and use that. I'm trying to specifically only give you enough time that you have to just think this through. If you're trying to solve, you don't have enough time. So go ahead, try and think these two through and figure out what your answers would be for both. And then I'll pull in when the time comes. So 1 minute. On your mark, get set, go. All right, time's up. I'm gonna pull in here. By the way, thanks for being cooperative, guys. I'm being on the video. I think that's feels good. Feels good to actually have faces in here. Go ahead. Let's see for the first one, A, B, C, D, or E. Let's see what you guys decided on. Cool. Most people go and C here. Can one of those C believers jump on and explain their reasoning? Ade, were you one of the C's?
Yes, I was.
Sorry, by the way, it was 2 weeks went by after the first class. Am I saying your name right, or am I giving?
You are. You're getting it perfectly right.
Okay, so Ade, what was
my approach was just looking at the first statement, and I realized the two variables, so I just went BCE. And then I looked at the second one. There's still two variables. Find the value for. So I just thought just putting them together, and from the question we just did before, and finding the value for X and then implementing it on Y.
Boom. And I think that's probably what most people are thinking, right? There's that kind of high school rule we've learned. You need as many equations as variables. If you got one equation and two variables, hey, you can isolate one of the variables, but you can't solve and get a definitive value for it, so that's not going to be enough. So statement 1, not sufficient. Statement 2, not sufficient. Just for those who might be rusty with it, make sure we're all on the same page there. Statement 1, not sufficient. Out goes AD. Statement 2 is not sufficient. Out goes B. Together, we've got 2 equations, 2 unknowns. You can solve that presumably. So see, do you guys go ahead and solve that real quick? I'll give you 30 seconds to solve them together. All right. Who is our E person? Who picked E on this one? No one's gonna claim it.
I picked E.
Yeah. Was it with intention or a guess?
It was with intention.
Okay. Can you explain why is the answer E? You're right. Way to go, Ahmed. Why is it E?
Because you need 2 unique equations for 2 unknowns. The first state equation is the same as the second one.
Yeah. So I was teaching you guys a little lesson here about how the GMAT, just the level of sophistication, what kind of traps can we expect? And we want to know that so we're not paranoid about everything, but we do know where we should be a little more paranoid. The 2 equations, 2 unknowns is oversimplified. These are actually the same equation. This one's just this equation in disguise. I multiply both sides by 2. Effectively, if I said y equals 2x, and I said, what's y? You'd be like, I don't know. And I said, well, what if I also tell you this? Y equals 2x. Now, can you tell me? No, I just said the same thing again. Just because I write the same equation down 2 times doesn't mean you have 2 equations. So you need to check for that. There's a lot of little sly tricks they play, little traps they make, especially in data sufficiency, so you really need to be on your game. We still don't want to have to solve all the way, but we want to refine our understanding of these things. Exactly as Ahmed said, 2 unique or 2 different equations, and then yes, if you have 2 different equations with 2 unknowns, boom, it's done. The equation is just a multiple of the other equation. It is not a different equation. It just looks different. Any other situation, they are different. But if it's a multiple of it, it's not different. Cool? All right, so little high school math trick they like to mess with here. I'm going to pull in for the second one now. Let's see what we got. Okay, so more people saw through this one. Can we confirm on this one that are they actually different equations here? Yes or no? Are they? Nod of the head, shake of the head. Are they different equations here? Statement 1 and statement 2. They are. Yes. These are not just multiples of each other. These are different equations. So indeed, it would be sufficient together. But we have a few people picking B. Who's somebody picked B? Can somebody pick B? Grab the mic. B is the correct answer here. Can you explain why?
Because in statement 2, it's 4x minus 4y equals 8. If you divide both sides by 4, you get x minus y equals 2.
Yeah, an intermediate step, bless you. X minus y. I'm actually trying to take a stand with that bless you stuff. I feel like if someone sneezes, just don't say anything. You guys with me on that? Or no, is that rude? Not strong opinions. Okay, cool. I feel like that's probably where most people like. 4x minus y equals 8. Divide both sides by 4. X minus y equals 2. Julia, do we now know what x equals?
No.
Do we know what y equals?
No.
And yet we know what x minus y equals. And so this is actually a really important idea and something that this test is going to really push you on. A lot of people would see this and say, oh, so I need to know x and I need to know y. And they're right, kind of, but they're asking for too much information. If you do know x and you do know y, that would be enough for sure. And together this would be enough. But again, C is only your answer if they're not sufficient alone. And so statement 1's not, but statement 2 is, our answer is going to be B. This is an idea called the combo. And just a general idea in algebra is stop thinking in one variable. This is another reason why I like the stacking idea as well. It's like you're thinking of the group, the combo of variables. So the combo says start looking for this combination. Hey, if I can know what x is and know what y is, great, but I'm looking for x minus y as a group. I'd say there's 4 problems where I'm going to get x minus y to solve this thing, and 1 problem where I'd actually solve for x and solve for y to get this thing. Start thinking in combos. If they want to know what's 3xy, what do I really need to know? Or just chat it in. Type that in, please. What do they need to know if they want to know what 3xy is?
What?
Everyone type an answer in there. See what you're thinking here. What value do we need to know? Kevin's correct. If we know x and y, that would be enough. But do we need to know x and y individually here?
No.
What do we actually need to know? What value?
The
What would be
x.
enough? That doesn't require actually knowing the precise values of x and y.
X minus
Not
y.
the sum, Kevin. Not the difference. What do we have up here? Think of it like this. If I want to know what's 3xy, it's like I want to know what's 3 times xy. Do you know what 3 times xy is? Well, I already know what 3 is. So what do we need to know?
Cross multiply.
Take another stab at it, guys. EJ, you'd cross multiply if you had like fractions across an equal sign. This is when you cross multiply, like something like that. That's when you cross multiply. Okay, so what we need to know is, not seeing it up there, right there. So not the sum of x and y, not the difference of x and y, but the product of x and y. So if they were to tell you xy equals 7, do you see how that'd be enough?
Yeah.
That would mean 3 times xy would be 21.
If you didn't know that. So if you didn't know that, you could probably like find a way to do like y equals or x equals like 2 plus y or something like that. And I don't know, is there a way that you can figure it out if you didn't explicitly know xy equals 7?
With one equation, no, because you either the only way to know what x times y is to get xy. Yeah, that's actually a good question. Let's just take a little sidebar here. I don't know why I said that. I don't really know anything about law. But 3xy, if they want to know 3xy, and statement 1 said x plus y equals 5, is that sufficient? And so what you're saying is like we could substitute, right?
Yeah, but it's not sufficient
Because why?
because we don't know what the actual values of x and y are.
Yeah,
I guess
but it would turn
the
into...
only way you would find it is if you substituted and you found the values of each.
Yeah. Here's the thing. Remember, this is not an equation that we know. This is a thing we're wondering about. So we only know one thing. This is not going to be exactly as you said, not going to be enough to solve for x and solve for y. It's just one thing we know. So if you substitute it in there, you could reduce the question to a one variable question, but you don't know what y is still, so you still don't know what this thing is. Yeah, so to get this with one equation, it's going to have to tell us what xy is. And they could disguise it, they could say x equals 5 over y. That could be statement 1. And then EJ, cross multiply that, and you'd get xy equals 5. And so they could disguise the xy information a little bit. So that's the idea of the combo. Start thinking in terms of I want to find that group of variables, that group of unknowns over, if they want to know what's x squared minus y squared, I'm looking for this. I'm not necessarily just wanting to solve for x and solve for y. They probably have a C trap in there where together we could solve for x and y, but maybe with one of them alone, we can get x squared minus y squared as a group. Questions? So, remember, watch for the combo. That's the lesson of this. Look for that combination of variables, if you can. Not just the individuals that compose the combination. That's a higher demand for information you're putting on it. So you're setting yourself up for C traps. And remember with the variables, number of variables, number of equations idea, it's a correct idea, but you need a refined version of it. You need the same number of different equations, different linear equations. Once we get squares and stuff in there, that screws things up too. Same number of linear equations as unknowns, you can solve for the unknowns. Once the equations are the same, it's going to mess with that. Okay. Let me try this for you guys.
Also, Joe,
Mm-hmm.
very quickly, is it possible to, for the bottom question, you know how we're supposed to do the AD, BCE?
Mm-hmm.
How would we go about doing it for this question?
If you did statement 1 first, AD would be out after you look at statement 1. And then once statement 2 is sufficient, you'd circle B. You only check CE if statement 1 and statement 2 are each not sufficient. That's the only time you check them together.
Okay.
Cool. All right, here we go. Try this one. Talking timing real quick, you should be having a little itch now. Is this going well? Finish. If not, that's where you should be thinking about wrapping it up. Okay, here's how I'm going to start this off. Fun question here. I'm going to launch poll. I would like you just tell me, just go ahead and pull in A if you tried algebra, and B if you did something else to try to solve this problem. So A for algebra, meaning like you tried to make some equations with variables, and B for you tried something else. Even if you didn't get very far with the algebra, if that's what you were trying to do. Okay, so most of you are trying algebra. Find out what the other folks are doing. Give a quick spoiler alert, that's kind of the point of this problem. This is a great example of how this is not really just a test of your algebra skills. I do want to make a point about algebra. I want to give you guys a process because algebra is an important part of this test. You need to be able to solve some problems using algebra. It's a big tool. It's a really good tool. The most important part, and I think something people don't realize is the thing that's tripping them up if they're struggling with algebra. Most people think if they're struggling with algebra, it's like, I'm having trouble translating the words in the math. That may be your problem, but that's the less common problem. And I think something that's very quickly improvable for the most part. The more common problem is poorly defined variables. Really work to define exactly what your variable is representing. So, Shel, what would be a variable here that we could create? You're on mute.
Numbers of toothbrush.
Cool. So we can. I recommend like descriptive variables like n, number of toothbrush, something like that, rather than just being beholden to x and y. We want to get a feel for these, and just remember, it's if you ever say like this variable represents toothbrushes, you're gonna get yourself into trouble. It needs to represent a specific numerical thing. It's never a noun. Because there's many things about the toothbrushes: the original cost, the later cost, the number of toothbrushes originally, the number of toothbrushes later. So if you just say toothbrushes, some ones might get away with that, but often that's going to get you into trouble. The other thing, the other unknown here, a good place to look is what they're asking for. What's our other unknown here? Shut.
Cost of toothbrushes?
Yeah, cost C or price, sure. Either one will say C. Original cost of a toothbrush. One toothbrush. So just being very specific. When people are kind of hand wavy here with their unknowns, that's when creating equations, when you're like, God, it's so hard to make the equations, I don't know what to do. Well, it will be that because it doesn't make much sense if you don't know what the unknowns represent. It's hard to make sense of your equation then. So it could be that you're having trouble with the language. If you're having trouble making your equations, much more often it's that you have illy defined variables. So take that time. What exactly is my unknown? Once you have that, a really common two big equations to be aware of: profit equals revenues minus costs. Just be ready with that. And the other one is price times quantity equals the total. Just an equation to be very aware of and ready to use. Comes up in verbal, actually, sometimes too, in critical reasoning. So here, the price of a toothbrush, C, times the number of toothbrushes, N, equals the total cost, which they said we got $60 in our pocket. And then from here, we're just saying, look, we get a discount of $1. Well, if the cost of a toothbrush is C, a discount of $1 is C minus 1. And that should hopefully make a little sense. And if the number of toothbrushes is N, 5 more toothbrushes is N plus 5. So our new number of toothbrushes is N plus 5. Our new cost is C minus 1. So our price times our quantity, and they said it costs the same amount, equals 60. If you set those up, high five yourself, mini high five. But if you got to this far, then you probably had this moment where you're like, oh God, this looks ugly. And it is. And if it took us a while to get there, this would be a problem where we might say like, crap. Unless I'm really confident in my algebra skills, probably best just to cut bait here on this. If I were going to guess the answers, what answer choice makes no sense? Let's take a step back, zoom out. Which of these choices just makes no sense even if you can't solve?
$1.
$1. Why, Kevin? Julia agrees. Why, Kevin?
Because the second sentence, I guess, or the second part says that you get a discount of $1.
So what would the new cost be?
It'd be $0.
Yeah, how many toothbrushes can you get for $0?
As much as you want.
A lot of toothbrushes. And they cost $0. So yeah, that just doesn't make sense. So $1 cannot be our answer here. Expect those answers to be there every time. If you get stumped, something goes wrong, zoom out. If I understand the question and I understand the information, even if I can't figure out the calculation, I should expect 1 to 4 common sense eliminations. They're not always there, but they almost always are. And sometimes you can get a lot of them. Okay, cool. So I'll say this is solvable. If you want to solve it for homework, I'll give you the first step. They want to know the price, so we're going to have to use substitution here. So isolate the variable you don't want, and so we'd isolate n. N equals 60 over c. Substitute that, and now you just have c. I'll tell you, if you then like FOIL, it's going to get real ugly. You'll end up with a quadratic equation. Wow. I'll solve that maybe during the break if you guys really want me to, but it's not really the point of this problem, so I'm not going to do that. And it's not really the kind of, if you're doing that kind of algebra on the test, you're doing it wrong. Who solved this another way? This is maybe a little bit of a magic show moment, but there's another way to do this. Who solved this a different way?
I did.
Julia did. How did you solve it, Julia?
So I decided to start off with, I decided to do like a substitution type thing, because they have numbers in the answer choices.
Can you elaborate what kind of numbers in the answer choices?
The original price.
Are you afraid of multiplying by 3 or adding 3 to things in general in life? No.
Yeah.
So not only are they values, but they're really friendly looking values. So
Yeah.
this problem is a bit of like a setup of, it may be deceptive in that usually there's 2 decent ways to approach a problem, and one might be a little bit better. This one was like really a dead end for most people if you did algebra, and like a really, you'll see, nice solution if you use numbers. I think the giveaway is look at these nice numbers. You shouldn't be thinking of plugging the answers as a trick, but as a viable equal to algebra approach, and this one's just ready-made for it. So this should be our approach here. Every now and then, we're wrong. And like, this looks really pretty and it ends up being really ugly. Oh well, but we take our best shot. Okay, how does that work, Julie? How do we plug in the answer choices?
So I decided to start off with 4.
Start in the middle.
Yeah, start in the middle because then I would know if I needed to go up or down.
Okay.
And so I did 60 divided by 4 is 15.
Yeah, and just recognize, guys, we don't need an equation for that. If you take $4 per toothbrush and have $60,
On 15 toothbrushes.
it feels a little more intuitive, or if we wanted to. That's the nice thing with numbers over variables, just like when we were picking the numbers last week. Okay,
And
cool.
then I thought about what would happen if I start off with 4, $1 less per toothbrush would be $3 per toothbrush.
So our new price is $3.
So I did 60 divided by 3 to get the total number of toothbrushes that you could buy for $60, and that was 20. So I got the right answer right there.
$3 a toothbrush, you got $60 in my pocket, I can buy 20 toothbrushes. And again, it's not that you're not allowed to use equations, you are, but the feeling should be, the numbers should make it intuitive, like what you should be doing. Don't build equations and then plug into them, that's not the goal. Cool, and so what does this mean?
So that means we found our answer.
Why?
Because, so 20 is 5 more. If you go back to the question, it says she buys 5 more toothbrushes than she originally planned. So with the discount of $1 per toothbrush, so she bought 20 toothbrushes.
Yeah, boom. Yeah, basically it will either contradict itself when you plug it in. At some point you'll get a piece of information that's contradictory, it's wrong. Or it all lines up beautifully and it's right. We're done. I'm gonna make a push for it, although C worked out quite nicely here because it was the answer.
Yeah.
B, D is generally the better option.
Oh, okay.
And here's the reason why. I'll just show you real quick here. So if you plug in 3, let's just practice this. EJ, can you jump on? If you got $60 in your pocket and toothbrushes cost $3, how many toothbrushes can you get?
$20.
Boom. Cool. Now we're going to discount them by $1. Now how much do the toothbrushes cost? How much did they? Okay, remember, so when we're doing B, we're saying the original price. This is the thing they're asking for. What is the price of a single toothbrush? We're going to say, let's assume B is the answer. That means the original price is $3. So after we do a discount of $1, what's the new price?
2.
Boom, brilliant. Okay, for $2 a toothbrush, $2 a pop, how many toothbrushes can we get for $60? Or another way to think about this is, we could say if there's 5 more toothbrushes, that'd be 25 toothbrushes now. An original. How much money does that cost? $2 a pop, 25 toothbrushes at $2 a pop. If we're buying 25 toothbrushes and each one costs $2, how much does
50.
that cost us? Boom. And that's what we want. You want your kind of magic brain to do the work there. Boom. So $50. So is B our answer? What was it supposed to cost? According to the problem. After we get our discount and we get 5 more toothbrushes, what's the final cost?
50?
That was according to when we plugged in B, but if you look at the problem, read on, starting in the second line, how much were we supposed to pay?
We were supposed to pay 60.
You got it, $60. So that's what happens when you plug in an answer that's wrong. It doesn't all work out the way it was supposed to. So B is wrong. Some problems, it's very obvious whether you should get bigger or smaller. One advantage of B is we have actually a twice the chance of being right. Because if we knew B were too big, if B could have been right, and also if B were too big, we'd also be done, because then we would know A is our answer, because all these would also be too big. So it doubles your chance of being done after one go if you do B first or if you do D first. There's also a lot of problems where it's hard to know, and I'd say this is one of them, where I know that 50 is too small, but does that mean my answer I plugged in was too small? I don't think it's immediately obvious to me whether I should take a bigger or smaller answer here. And so this is where B and D really are an advantage. That's the case on a lot of problems.
It took 40 years to
so we try D next. $5 toothbrush, we can get 12 toothbrushes. $1 discount, so now $4 a toothbrush. We buy 5 more toothbrushes, that'd be 17 toothbrushes. $4 a pop, 17 toothbrushes. 17 times 4 is 68, but it was supposed to be 60, so D is also wrong. And then you can look at the trend. We knew it's supposed to be 60, so the trend means, oh, we're supposed to be between B and D here. So C is the answer. So you should never have to plug in more than 2 answers if you're doing BD. Never. C, if you know the order, it's the same deal. You shouldn't ever have to plug in more than 2. But if you don't know like whether you should be getting bigger or smaller in your guesses, you might end up having to guess as many as 4. So use BD when you're plugging in. It's generally just a superior way to go about it. In general, it's about speed though. So if B and D were like 3 pi and like root 7 over 3, I might be like, I'm gonna try C first if C is a good looking number. Like I want to try clean number. Questions? This? Yes, this is the 700 level question for sure. And it's so easy when you plug in a number. I'd say that tends to be the case. The hardest math problems are the ones where the obvious standard approach is very tough and alternative problem solving methods to the standard algebraic approach are the bigger payoffs. That's where they're really testing like how creative and clever of a problem solver are you. Like you either better be just a guru of algebra if you're going to get this using algebra, or you better be a creative problem solver. Questions? So, big thing. When can you do this? And this is your number one priority practice this week. You can do this when there are values in the answer choices. Think of that. Last week was when there are variables in the answer choices, make up a number. When there are no variables in the answer choices, plug them in. That covers most questions. What caveat is they have to be asking for an individual amount here, like the price of a toothbrush? If they ask for like a sum of things, like what's the sum of the number of apples and bananas bought at a store? We can't really plug into that because if we plug in like 10, there's many possibilities for that plug-in. It could be like 9 apples and a banana or 8 apples and 2 bananas. So if they're asking for a combination of things, it kind of defeats the plugging in strategy. But if there are nice looking numbers down here and they're asking for an individual thing, plug in the answers. Do it. It should be your first go-to. Even if you're pretty darn confident in your algebra, plug in those answers. And if you don't practice that in homework this week, you'll never do it on test day. So make that your own strategy this week. See the ins and outs of it. Questions? Homework assignment to solve the algebra for this problem if you want to do that. It's good thing to practice. Okay, here we go. Here's a data sufficiency problem here. So use your grid. Try this one. Okay, start pulling in your answers. Give you another 20 seconds or so, 30 seconds tops. Okay, we got a nice variety on this one. This is fun. But there's a big hump at 3. Can someone explain? I feel like there's decent reasoning. Or sorry, on C, not 3. Can someone explain to me the reasoning for C? Someone to pick C.
Yeah, Joe, I picked C. This is Kevin.
Thanks, Kevin.
Well, looking at, so there's 1 and 2. Looking at 2, x t minus x equals 5. So that can kind of, so in the initial question,
Mhm.
you can say, denominator t minus s, you can say that equals to 5.
So you can substitute that in for this denominator. Yep.
You can do the same for the numerator or part of the numerator.
Yep.
But then the other part, 2t, you would need part 1 to solve, which you
It's
could.
the missing piece. Yeah. Go on.
Which you could. So I know for sure. I know for sure that if you use 1 and 2, you could solve it.
What happens if we use them together? What could we definitely do if we use them together?
Yeah, if you use them together, you definitely could solve for the
Why?
part.
How do you know that?
Because I know that 2t. So the last part here, you're looking for what is equal to 2t.
Yeah.
The top part, the denominator of the top part, t minus x, you can say 5.
Yep. Okay.
So in the equation that you
This is
wrote,
actually-
that's basically
Behind Tayo is the
just
Joseph
the
Smith
first
Memorial
equation,
Building.
And we know this is 5.
40.
and that equals 5. Yeah.
So we know 2t is cool. I'll give you another way, and maybe some of the other people picking C might have been thinking this way.
Cool here.
If we just do this a little more,
Very hot right now.
a little more
We don't
work
need
on
any
that
perfect.
statement
Yeah,
1,
it's like 70
and now we
degrees.
combine like terms.
So I could
You
either
can
take
get
a
like
photo of
t
you over there,
minus
or
3x,
over there. And if-
subtracting 2t from both sides, equals 0.
Miss a lot of it. Yeah. Okay. Let's do.
And t minus x for statement 2 equals 5. What do we have?
Tayo,
And we can bring these together. What do we have?
for you.
2 equations, 2 unknowns. Are they the same equation? Absolutely not. So, without a doubt, we can solve for t and x. And if we have t and x, without a doubt, we've solved. We're done. So, E is out, is what that tells you. Beyond the shadow of a doubt, E is out. They definitely work together. We've got 2 equations, 2 unknowns, 2 different equations, 2 unknowns. So we can solve for, solve together. I would say this is a big C trap, and they want that thinking of like, oh, I've got 2 equations, 2 unknowns. Remember, C is only our answer if they work together and not on their own. Yeah, you can kind of see the statement 2 trying to plug it in, like we're not going to be able to get that T here. So if we wanted to, we could flip this and do BD KC. Statement 2 is definitely not enough. Together, not enough. So we're down to AC. If you just got this far and you're just kind of looking at statement 1 confused, you should be guessing A. Guess away from like an, if it felt like C was obvious, like obviously these are enough, you should be guessing away from that, generally. So, did anyone see the algebraic move here to get it? I'll tell you guys, statement 1 ends up being sufficient. There's a couple ways to show it. One is by manipulating this. One is through substitution of some kind. Anyone get there? Ahmed, did you get there? Yeah, you're muted if you're talking, Ahmed. If not. Ade, did you get? Yeah, Ade, did you get there?
Yes, I did.
Cool. How did you do it?
I did, for statement 1, I did 2t equals, I found out what t was, so I found out t equals 3x,
Cool. So we just did this, the simplification of statement 1.
and then I put it back into the yep. And
So-
then,
So recognize when they ask for an expression like this, for it to be sufficient, it needs to all boil down into a number. If there's any variables left, that means
So
we don't
we're
know.
here at
All right, so go on.
Square.
What do we get?
so I got 2, I ended up getting 6x plus 2x divided by 2x, and then I divided that, and I got a value of 4.
Cool. Yeah. If you just combine like terms of here, 2t plus t is 3t. You plug in t equals 3x, you get 3 times 3x minus x over 3x minus x.
So you
And you
get
get,
6x plus 2x divided by 2x.
careful, it'll be 9x. Doesn't end up mattering here.
Yep.
So 9x minus x
Yep,
is
yep.
8x
Yep.
over 2x.
Yep.
Ka-cha.
There you go.
And so our value ends up being 4. So it rephrases the question to what is the value of 4? which we know the value for is 4. That's one way to do it. The other way is through rephrasing the original one in a way that might feel counterintuitive. But I'll show you the move here. Get ready for this. They like to just mess with this. If we have like a over 2 plus b over 2, people are pretty comfortable saying, well, that equals a plus b over 2. Usually that's what we're doing. We're combining fractions. But just remember, you can go the other way. If you have a fraction where it's like things are being added over a number, you can write it out as 2 separate fractions. When should you think to do this? When something in the numerator, one of those terms matches the denominator. So if I have a plus b over c, I'm not going to do it probably. I could say that's a over c plus b over c, but I'm not thinking to do that unless I'm seeing like a over c's and b over c's somewhere else in the problem. So probably wouldn't do that. But if I see a plus b over b, without a doubt, I'm going to do that immediately. That is a over b plus b over b, which is 1. And that in some ways is simpler than the first one. Or at least equally as simple, so worth looking at. Because if this was a question asking me what's a plus b over b, I can simplify that to what's a over b. That's what I would need to know. So here is the big first glance moment we would want to see here is there's a match. It's kind of all over the place, this thing. Kind of driving that at us. So hey, let's split this thing. Let's rephrase it. 2t over t minus x plus t minus x over t minus x is a rephrase of the question. This is just 1. So what they really want to know is what's 2t over t minus x? If we know that, we know what 2t over t minus x plus 1 is. And statement 1 tells us it's 3. So this is the combo. There's that idea. They love messing with that. If you're just seeing that and saying, I need to know what x and t are, you might get into some trouble. You don't have to, that's a pretty clever algebra move. I told you now what to look for, so maybe try and remember that. If you see a match in a fraction, in the numerator, a term in the numerator with the denominator, split it. It's a good rephrase. Might pay some dividends. That's one of 50 nifty algebraic moves. So I think the bigger idea is thinking about combos, and I think knowing how to substitute into a question what needs to happen for it to be sufficient is important. Questions on this?
How do you determine the strategy again? The ADBCE or ACBDE?
Oh, no, the two ones are right. The two possibilities are ADBCE if you start with statement 1, or BDACE. So you just flip the B and the A if you start with statement 2. So if we're like, I'm not sure about statement 1, but statement 2 I know is not sufficient, then do BDACE.
Okay.
So start with that easier statement, or if you get stumped by the first statement, effectively you're starting with the second statement now. And so that would be BD is out. If statement 1 works, then we're done. A is our answer. If statement 1 didn't work, we'd cross out A and we'd try them together. And if they work, we pick C, and if they don't, we pick E.
In this case, we know that A is sufficient.
Yes.
So we did the ADBCE strategy, right?
I ended up, the way I did it was I said, I know statement 2 and I'm not sure about statement 1. But yes, if it had gone that way for first, I know statement 1 is sufficient, then we would say boom.
Okay.
We would use that one. And then I'd look at statement 2, and if it works, I'm going to pick B. And if it doesn't, I'm going to pick A. And I'd say statement 2 is not sufficient, so I pick A. Cool. Other questions on this one? Cool. Watch for the combo. That's the biggest algebraic shenanigans they play. It's not crazy tough algebra, but it's just, are you only thinking about individual variables? Then you're gonna test lower for that. We want to see if you can think of a group of variables as a single entity. If you can, you'll test higher. That's what they're getting at. And knowing what the test takers are getting at is, I think, an important step in your studies. What's the games they're playing? What are the games they're not playing? That's a game they're playing. want you to glance at this one, and I want you to tell me in 15 seconds, I want you to type into the chat, what are 2 different ways we can approach this problem? Go. Everyone do it, even if Mr. Shutt has beaten you to the punch. Cool. Yeah, so we've got, awesome. This is your first thought on a problem. It doesn't need to be in the first 15 seconds, but before you start approaching a problem, before you actually put that pen to paper and start working on it, the first step is think about what's possible here. For instance, that last data sufficiency problem, if we were being realistic, I should have said, could we pick numbers here? And you could have, but it'd be a bad choice because it's such complex things that are going to require a ton of computation. So, but it should be a thought that crosses your mind. Can I pick numbers? Yeah, but I'm not going to. Here, I really want to do algebra. What else could I do though? I could plug in. You need to have that thought. I like it though. Shutt, that you have these other ideas too. Smart numbers we can't really use here, just if we're being clear about what smart numbers is. That's where you make up your own number. We can't make up our own number here, but we can plug in. We can definitely guess and think about what makes sense. We can make variables and try and solve that way. I want to push you guys to all try and plug in here. And I'll tell you there's another cool way to do this. I'll show you. It's a little taste of what we'll do in week 6. But go ahead. I'd like you guys to try plugging in. The math is going to be a little bit trickier. Remember to use BV, go for it, put it to the test. Okay, let's see how this is going. Chuck, can you show us how to plug in? And even if whether it went well or not, let's figure out how this works here. Remember to unmute before.
Sometimes I try using the space bar and then sometimes it doesn't work. Unmuting. So I know that you told Julie earlier to do B or D. I still went with C.
God dang it.
I'm sorry. So I did 25 days minus the final 6 days.
Okay, cool.
Where we were reading.
So how many days originally would that be then?
25 was what I used as the original whole number. Oh, so 19.
Yeah,
19.
cool. So just to recognize what you did really well there, and I want to call it out, is the first step is always like, what am I picking for? What am I plugging in for? So look at what they were asking for. We are assuming whatever they're asking for is the answer. So we're assuming the total number of days is 25 minus the 6 days gives us what? 19. And what does 19 represent?
The days that she was reading at first, 75 pages per day.
Awesome. So see what you've gotten yourself into here. I gotta do 75 times 19.
It's a pretty friendly number though, 1425.
How'd you do that so fast?
75 times 20 would have been 1500 minus 75.
Really good mental math trick. Find those tens. Tens are really easy. So 750 is 75 times 10. 1500 is two 750s. We're one fewer than that though, so minus 75. Nice move. So that's 1425. Then what?
That's as far as I got.
All right. Well, let's see if you can do it on the fly here. What's next?
That's how many pages she read in the first 19 days.
And then what's the next thing that happens?
Next thing that happens, I don't know.
Well, just the very next line. So 75 pages per day at first, and then what about those other 6 days? They tell us.
690 over 6.
Cool. So 690. That's the rest of them. So how many total pages do we have?
Whatever that is, 2,115.
Yeah, it's getting ugly. So we have figured out that there must be 2,115 total pages. What's the last piece of information we haven't looked at? What? We used the 75, the 6 days, the 690. What's the last piece?
That she planned on using 90 per day.
So we're supposed to do 90 per day. So what do we do with that 90 then? Remember what? Yep.
We do that total over 90. Right?
Total over 90, or we can do 90 pages per day times supposedly 25 days, whichever one would work. It doesn't work out. So 90 times 25. What would 100 times 25 be?
250.
Or 2,500 minus 250 is 2,250.
Yep.
So what does that tell you about C? You muted, but yeah, not our answer. It was supposed to come out to 2115, but it didn't. Okay, so we can see where it's like, you know, I gave you like an ideal problem before. Like, this isn't always like some easy move. This is why I want you guys to practice it. You can gauge how long is it going to take you, and you also need to be smooth with it. So on one that's kind of challenging, where there's rough calculation like this, you can move through it quickly and really just, if you can get the calculations done, you have the problem done. If you combine that computation time with also being uncertain about how to approach it, that could break you. If we start with B and D, who wants to give B a shot? Adi, did you try B? Kevin, did you try B? One of you wants to grab the mic first. And no? All right, well, Kevin, I'm going to make you do this on the fly then. So plugging in B, what does that mean if we plug in B?
Well, the reason why I didn't plug in B for any number is because the wording of the problem is confusing. But
I'll say plugging in numbers is usually your best shot at making sense of the problem, because now we're working in numbers, we're working in a land that's very concrete. So if we're plugging in B as a boy, if we're plugging in B, what does it mean? What do we know to start with?
This person has total 16 days to finish all the things.
Okay. How many days did we spend at first? Reading the 75 pages per day?
10.
Cool. That'd be the first 10 days.
10 times 75, 750 pages.
And then 690.
Yeah.
And that adds to?
1440.
Yep. And if you guys are trying to work on your mental math, the key is left to right. So 700 and 600 is 1,300. Little decent mental math skills can really be helpful. And then 50 plus 90 is 140. So 1,300 plus 140 is 1,440. Work on that. If you guys, it's good that you're not going to forget how to stack them and add them and carry the one and stuff like that. You're not going to forget how to do that. So it can't hurt to push your mental math skills a little bit so you don't always have to do that. Okay, cool. And then if we're supposed to be doing 90 pages a day for 16 days, how many is that?
1380.
Nope. 90 times 10 is 900. What's 90 times 6? What's 9 times 6?
54.
Yeah, that'd be our math move. So 90 times 10 is 900. 90 times 6 is 540. 900 plus 540 is 1440. And even guys, if this took you a minute, you're much more likely to have you're more likely to work out what to do with the numbers doing this than with the algebra here. If you weren't able to do it, okay, well, it's still tough. This isn't like easy, like magic wand type of move, but it is easier as far as what you should do with the numbers. The downfall is computation, at least the downside, not the downfall. And that's where a little mental math stuff can help that be less of a downside. Anyway, it works out. So B is our answer. Done. If it hadn't, if you're doing BD, the good news would be you only have to try one more. At most, you're going to have to do this calculation twice. And usually the second calculation is quicker because you know exactly what you should do with the numbers. So you that took you a full minute and a half, like, hey, maybe the second one should only take us a minute, and then we're done. And then there's a longer problem, but we have an answer. Here's what the algebra looks like, real quick. Here's a big equation to be familiar with. Average times number of terms equals sum. Most people are used to seeing it as average equals sum over number of terms. Start thinking about it this way. They're almost always asking for it and thinking about sums. Here we have multiple averages. So the average of 75 at first, and that was for, if there's n, we could say n for n days. So that would be a sum of 75n. And later we have 690 days over 600, a total of 690 over 6 days. So the total would be an average of 90 for n plus 6 days for a sum of 75n plus 690. And that's a single variable equation. That's tough. It's one of those things where maybe, depending on where you are in algebra, you might look at that and be like, dang, that doesn't look that hard. That's very hard to organize all that and keep it all together. You're having to understand what all these things mean in abstract land. It was hard enough when we had a number for it. Hey, there's 16 total days. How many days at first? 10. 10 total days. How many days at first? Like, that's just too much sometimes. So that's the algebra. I'll just give you a taste of what's to come.